Hi student, we prove the corollary on indefinite integration. We have already proven corollary by using the substitutions method, and this is the second corollary. We prove this corollary by the help of the substitutions method. Here integration f of x to the power n into f dash of x into dx is equals to f of x to the power n plus 1 upon n plus 1 plus c. That is, here LHS is given, and from this LHS we prove that the RHS, that is f of x to the power n plus 1 upon n plus 1 plus c. So first we write, here it is given that n is not equals to minus 1. So first we write here the left hand side is equals to integration f of x to the power n into f dash of x into dx. This is our left hand side. We write here LHS, and LHS is equals to f of x to the power n into f dash of x into dx. Then we use here substitutions method and prove that the RHS f of x to the power n plus 1 upon n plus 1 plus c. So we put here f of x is equals to t, that is this red color function f of x is equals to, here we put t. Then differentiate both sides with respect to x. Here differentiate both sides with respect to x. Then ddx of fx, and by denote ddx of fx, that is f dash of x, is equals to dt by dx. So this can be written as ddx of fx f dash of x into dx is equals to dt. Therefore this LHS becomes, LHS is equals to, right here LHS is equals to integration, so right here integration fx, but fx is equals to t, so right here t to the power n into dt is equals to, again we repeat this, fx is equals to t, so right here t to the power n, so right t to the power n, f dash of x into dx, here f dash of x into dx is equals to dt, so right here dt. Then we use here the formula. We know that the formula integration x to the power n into dx, that is x to the power n plus 1 upon n plus 1. Similarly here t to the power n plus 1 upon n plus 1 plus c. Therefore left hand side is equals to, here t, but t is equals to fx. So we write here t is equals to fx to the power n plus 1 upon this n plus 1 plus c. And this is our RHS. Therefore LHS is equals to RHS. Here left hand side is equals to right hand side. And this is the proof of the second corollary by the help of the substitution method. Next, we prove the third corollary by the help of the substitutions method. And here the third corollary is to prove that integration f dash of x upon root fx into dx is equals to 2 under root fx plus c. Again we write here LHS, that is left hand side is equals to f dash of x upon root fx into dx. We write this here. Next we use here the substitution method, and again we put this fx is equals to t, root fx is equals to t. This red color function is equals to t. Differentiate both sides with respect to x. Then ddx of fx f dash of x, we write here f dash of x, is equals to dt by dx, we write dx is equals to dt. Therefore this LHS, their LHS is equals to integration f dash of x into dx So f dash of x into dx dt. So write here dt. Here write 1 upon fx is equals to t is equals to integration multiply numerator and denominator by 2. So we get 2 into 1 upon 2 into this root t. So write here root t into dt. Therefore LHS is equals to 2 integration this 2 constant. So write here 2 integration 1 upon 2 root t into dt. And we know that 1 upon 2 root t is the derivative of the function root t, because integrations and derivative are anti-process. So this 2 as it is, so right here 2, 1 by 2 root t is the derivative of the function root t, that is integration of 1 by 2 root t is root t plus integrating constant c. Therefore this LHS is equals to 2 as it is. This 2 as it is here. Root t, but t is equals to fx. So right here fx plus c. And this is our RHS. Therefore LHS is equals to RHS. In this way, by prove the third corollary with the help of the substitutions method. Next, again we prove one corollary with the help of the substitutions method. Prove that integration f dash of x upon fx into dx is equals to log mod fx plus c. So first we write here left hand side, and LHS is equals to integration f dash of x upon fx into dx. Again put here fx is equals to t, use here substitution method and put this fx is equals to t. Differentiate both sides with respect to x. Again ddx of fx f dash of x into dx is equals to dt. Therefore this LHS left hand side is equals to this integration, here integration f dash of x into dx, here dt, so write dt. Then fx t, fx is equals to t, so 1 by t. And 1 by t is the derivative of the function log of mod t plus integrating constant c. Therefore LHS is equals to log of mod t, but t is equals to again fx. We write here t is equals to fx because we want answer in terms of x. So log of mod of fx plus c, and this is again LHS is equals to RHS. This is the proof of the fourth corollary. Next, with the help of this corollary, we prove or we evaluate some simple problem on indefinite integration. First problem, evaluate integrations of tan x into dx. Let I is equals to integrations of tan x into dx, that is the given problem. Here we find the indefinite integrations of the function tan x with respect to x. So we denote these integrations of tan x into dx is equals to I is equals to integration. Tan x can be written as, we know that the formula for tan x sin x upon cos x. So right here sin x upon cos x into dx. Then we put this red color function, that is the cos x is equals to t. Differentiate both sides with respect to x. We know that ddx of cos x minus sin x is equals to dt by dx. This can be written as dx is equals to dt. Therefore sin x into dx is equals to minus dt. Therefore I is equals to integration this sin x into dx, so right here minus dt upon cos x, so cos x is equals to t, minus integration dt upon t, minus 1 by t is the derivative of the function log t plus c. Again we put here t is equals to cos x. So I is equals to this minus sign as it is, so right here minus sign log t, but t is equals to cos x plus c. Therefore I is equals to here we use log m raised to n log m. Therefore, log cos x to the power minus 1 plus c. I is equals to log of, use here indices rule, a to the power minus 1, 1 by a. Therefore, 1 by cos x plus c. Therefore, I is equals to log of mod of, we know that the formula 1 by cos x sec x plus c, and this is the indefinite integrations of tan x with respect to x is log of mod of sec x plus c. In this way, we evaluate the indefinite integrations of tan x with respect to x by using the substitutions method. Again, we solve one problem, that is evaluate integrations of cot x into dx. Again, we find here the indefinite integrations of cot x with respect to x. Let this integrations of cot x into dx is denoted by I. I is equals to integration cot x into dx is equals to integration cot x. Cot x can be written as cos x upon sin x into dx. This is the formula. We know that the formula, trigonometric formula for cot x, that is cos x upon sin x into dx. Then we put this sin x is equals to t. We use here substitution method. Put sin x is equals to t. Differentiate both sides with respect to x. ddx of sin x, so right here cos x into dx is equals to dt. Therefore, I is equals to here I, this is equals to integration cos x into dx, but here cos x into dx is equals to dt, so write dt. Sin x, but sin x is equals to t, so write here t is equals to, again 1 by t. 1 by t is the derivative of the function log t. Therefore, integrations of 1 by t with respect to t is log t plus c. Therefore, I is equals to log of mod of here t, but t is equals to sin x, so right here sin x plus c. In this way, we solve the second problem, that is we find the indefinite integrations of cot x into dx by using the substitutions method. Dear student, if you like my video, please subscribe my YouTube channel. Okay, thanks.